Well, welcome folks. So we're going to have a bit of a talk about some experiences we had with Event Hubs and scaling Azure Functions against SQL. So I hope that's what you're here for. If not, then enjoy the seats. So I like chocolate cake, and the objective is we need to eat that chocolate cake. We've got two ways of doing that. We can either find someone that is very, very hungry and has got a big appetite and can eat that whole thing, or we can get a whole group of people eating a little bit of it, and then the cake will be gone very quickly. Now, I can imagine, if any of you got teenagers on Facebook, the thought of having a Facebook party where they just go and like put a little, we're having a party, everyone comes around the house. If you suddenly have a few thousand people come around your house, you're going to have a few problems. If you put that cake in the middle of a load of people and you said, go for it, go and eat it, you're going to have a load of problems. And that's what you end up with Azure Functions if you don't think about what you're going to do. And hopefully in the next 20 minutes, we're going to go through some of those learnings that we went through as we tried to investigate Event Hubs and Functions, and how that relates to SQL Server. Oh. So I'm Simon Sabin. I run a data consultancy in the UK, and we specialize in data platform and DevOps. And so we're trying to move the data platform, data ingestion story into the new age serverless technologies. And we had a gaming company that wanted to do customer matching. So if you imagine, they've got lots of gaming platforms, and they want to make sure that if a person is playing on one platform, that they know it's the same person that's playing on a different platform. So they've got to match these customers together. And the rules for matching those customers are fairly simple, but they need to be processed across the whole of the customer base. So they have the same surname, the same postcode, the same telephone number. And the business has got a lot of investment in SQL. And so we were looking to figure out how we could use SQL as a means of doing this matching technology. Now the other aspect is their end goal is that they want a real-time matching engine. They want to have an ability that they can go and just post a request to an API and figure out whether that customer matches to an existing customer. So that's the end goal, but initially we've got to match all their existing customer base. Now, there are a couple of options we can go for. We could write a big batch set-based SQL thing that goes and processes all these customers, but that doesn't really get us to this goal of being able to process a single customer. So we wanted to move to a single processing unit, but figure out how we could scale that to be able to process in the time that we wanted. Fundamentally as a business, and hopefully you guys as well, DevOps is really driving how you do your transformation and deliver your software. That means you need to be able to test your software, you need to be able to release it, and fundamentally you need to be able to monitor it. And so those are underpinning some of the decisions we made and why we wanted to go for Event Hubs and Functions and SQL. And one of the core aspects is batch processing is hard to test. And we'll go through that in a few moments. So if you're doing batch processing, if you're going to eat that whole cake in one go, the big problem is, I mean, I'm sure you've all had ETL processes or systems that are doing that big black box processing. Now, the problem is, if something goes wrong with that process, so there's one bad customer in your data set, the whole thing falls over. And the whole thing falls over, it means that you don't have any customer data in your end system. Additionally, trying to debug and test individual customers going through this black box is often really hard and often really slow. So the failure of a batch is the whole batch. Processing is hard because reprocessing individual units, because you've written your code to process a whole batch, so having to rewrite it to process a singleton is difficult. Debugging is hard. And fundamentally, you've got to find that person with the appetite to eat the whole cake. You've got to find a compute unit that can process all that data in one go. And that's a challenge. And in the serverless world, that's what you don't have. So the nirvana, we want to go to a world where we're processing one by one. So we take our batch of customers and we process each individual customer one by one using Azure Functions. That's what we want to get to. The benefit being, if one of those customers fails, then we don't affect all the other customer data. Once we fix that customer, reprocess some data, that customer can go through and we're good. And we talked about the fact that in the end goal we want to get to this real-time singleton processing unit. The nice thing about functions is we can inject into this pipeline and process one customer at a time rather than processing from a batch. So our solution was going to be Event Hubs with Azure Functions with a SQL Server database. And part of the challenge was, how many people have heard of Cosmos? How many people use SQL? So I'm sure there's a lot of pressure to go, oh, your CTO's heard that Cosmos is the scale, that's the ultimate thing. We should be using Cosmos, not SQL. Now, I'm a SQL guy, I have been for 20 years. I think SQL scales pretty well and does a lot of things very well. And so part of this was to try and prove how well SQL could scale. So the dream, this was the architecture we started off with, that we would have a function that would read our batch, break it into small chunks, and put that chunk as a message on an Event Hub. A function would then take that message off Event Hub and process that into SQL Server. Fairly straightforward. Yeah? I think it's going to be easy. So that's what we started off with. We had a single processing Azure function. Who's used Azure Functions yet? Okay? It's really, really easy. Essentially, all you've got to define is a single method and deploy that, and that's your function. Put some triggers on it, and when those triggers fire, your function fires. That's how it works. So this one goes off and takes in a message, which is the customer data, and goes and sends it to the database to be processed. So we've got a triggering process that we've set up that will process 16,000 customers. So this is simulating that batch process at the start that is taking all those customers and generating all the messages to put on the Event Hub. So that's gone through and it's processed 16,000 customers. Now, what do you think might have gone wrong in the world of just going and throwing 16,000 messages, events at an Event Hub and a function? Any thoughts? Pardon? Synchronization. Hitting the database. Interesting. Yeah, maybe. Anything else? So, pardon? The time of the functionality. Yeah? Options. So, the reality is, it was a bit chaotic. How many people have tried to write multi-threaded applications? Yeah? Did you start off going for each, very large loop, create a new thread for every single thing, and suddenly you realize, maybe that's not the right thing to do? So, from a SQL perspective, if you go and spawn all these functions, then they all are trying to make connections to the database. You have this thing called connection pooling, which reuses connections. You have a finite limit of connections. Noisy neighbors. Imagine you're having your chocolate cake party in your lounge and your mum and dad are trying to watch telly. That's not going to work very well. So if you've got functions in the same function app, then there's a bit of disruption and that can cause chaos. So we had a number of functions and they weren't working very nicely, and we'll explain why in a minute. The scaling isn't seamless, and that comes back to the noisy neighbor thing. As one function needs to scale to process more data, it can impact what else is running in that function app. Threading is the killer feature. How many threads are you starting, and how is that going to work? and what's that impact from a thread exhaustion on your server and from a connection pooling perspective. And fundamentally, it's not magic. You think, oh, function, you can just throw a million things at this server and it'll just consume it and process it. It's not the case. It's just a web app on a VM. How many cores do you think are on that VM? 2 cores? 4 cores? 16? 32? 1 core. In the consumption model, the VMs you run on are single core. They're cattle. They want to kill them, start them, kill them, start them. That's their model. So if we go back and look at what we've just done, so we just kicked off these processes, and let's see how we can see some of those scenarios that we talked about. So I'm actually storing that data in the database, and what we'll see here is the fact that only 13,000 of those 16,000 actually got through. So that's not pretty good. I've lost 3,000 of my customers. That's not great. What else? So if I look at the, some of the information in Azure Analytics, in App Insights, then this is the number of functions that have been started. And you can see at that point in time, 5,500 functions were tried to be started on a single VM at one time. That's going to not work very well, is it? Which then leads to some interesting exceptions. Actually, it's this one. Where we have timeouts occurring, and we're ending up with lots of timeouts occurring. Timeouts occurring, trying to get connections off the pool, and thread starvation. So fundamentally, we've got some bad stuff happening. So what is happening, and how does it all get architected under the hood? Well, you have an Event Hub. You start off with a single Event Hub, and you create partitions within your Event Hub. And you can go from 2 to 32 by default. You can go more than 32 if you make a call to raise a support case, but 2 to 32. What you then have is essentially your function VM. You don't see this. This is done magically for you in the consumption world. On top of that, there is essentially a web app with a function process event, a processor unit that is pulling the data off Event Hub. And the way that it's sort of partitioned and aligned is you have a unit that is aligned to a partition. And the function host will go and pull messages from the partition in a batch, and for every one of those messages, go and create a function call. Call that method for that message you've got. Once it's processed that batch, and they've finished, it'll go and do the next batch. And so it does it in batches, and it'll start all those functions in one go. So 32 partitions. By default, you're pulling 100 messages off each Event Hub, 3,200 functions being started in one go. That's going to cause problems on a single machine. So that then caused problems from a SQL perspective, not necessarily from a SQL perspective per se, more from a connection pooling perspective. So by default, anybody know what the limit on connection pooling is? Does everybody know what connection pooling is? Okay. So the default is 100 connections in a connection pool, and that's per app domain. And so after 100, everything is going to wait based on the connection timeout. And if it doesn't get a connection in time, it will go and throw an error. Additionally, from a SQL, so running against SQL Server, Azure SQL Server, you have a situation where there are fundamental limits about the number of connections you can make. So based on the different tiers, you'll see you've got different numbers of connections. So up until an S4, you only have 400 active workers. You can have 4,500 connections, but you can only have 400 active queries being run. Now, you can quite easily exhaust that. Now, interestingly, we hit the connection pooling limit before we got anywhere near that. So what you've got to figure out is how many connections do you want to have starting at any one time? And also, your downstream system, how many connections can that consume at any one time? So you've got to think about the VMs you're running on and the database server that you're hitting down the end. Now, as I said, SQL Server up at the higher ends can take 30,000 connections, and so that's a lot of threads running on lots of VMs before you can exhaust those limits. So really, it's more about understanding how your web app and your function can scale and can cope before you're going to hit those SQL Server connection limits. So how do we control this thing rather than it just being like a whole free-for-all, go and create all these messages? Well, there's one thing you can control, the batch size that comes down. You can control that, but also the better model and the model that really the function team advise you to use all the time is a batch model. And the batch model essentially changes this from a processing single messages to processing an array of messages. So you'll see here that you've got an array of messages, and then you can just loop through and process your messages in whatever multi-threaded model that you want to follow. So there's an argument that says, well, hold on a second. You said you didn't like batch processing. You wanted to process singleton messages. And it's like, well, yes, but the fundamental thing that I'm trying to achieve is to have my process of unit, my unit of processing being a customer, which I can test. So I can unit test that function very easily. Now, from an Event Hub perspective, or Event Hub triggering, you are always going to deal in a batch. From a failure perspective, we are still processing individual customers. If I have a failure, I need to send that failed customer to a poison queue or a reprocess queue, but I'm still processing individual customers. And then the batch thing means that I do have total control over how many threads I'm going to get. So this means if I've got 32 partitions, then effectively I'll have 32 batches being executed at any one time. So if I want to go up to 10 concurrent threads, 100, whatever, I'm much more in control. The other aspect is, and let me show you this, I will kick off running 32,000 for a batch. And App Insight's live metrics is just amazing. You can see all the messages being processed, the CPUs of the workers. You can see the number of VMs that are starting, that are running. So the longer that you run, that you've got demand for running more and more messages, the more VMs that get started. So we're now up to 3. But I've now processed all my messages, and I should find, if I go in the database, what I've got now is, not quite processed them all. Oh, maybe I lost them. My error handling probably wasn't as good. Not by default. You have to code that yourself. So any reprocessing. So by default, Event Hub triggering, I will process a batch. At the point I've got to the end of processing that, any exceptions just get swallowed, and whether I've got exceptions or not, that batch will get checkpointed. Yes, so you have to write your requeuing logic to go and put that somewhere else, either put it back on the queue or put it into a different queue. So, yes. But there's an interesting concept, and I'll go on to that in a minute. Let's see if this is... interesting. So one of the things I find now is I've processed 32,766 messages, but the only number of unique messages is 31,966. So my error handling in my sample is not fantastic, but the point being is that I'm processing more messages than I've got coming in. So why is that happening? We've got to figure that out. But what you should see, oops, from a time perspective, that batch model was processing 32,000 messages in 16 seconds. So that's half a millisecond per message. I'm saving a JSON payload of 600 bytes to the database, doing an index view on top of it, and that's what's been done in half a millisecond. With the singleton processing, I was processing 13,000, and it took me 21 seconds. So 4 times as long to process. And that's due to the overhead of the function execution model. So batch is your friend. It enables you to remove the overhead of the per function execution. And if you've got things like connections that that are costly to connect, then you can reuse those, and so you can really make optimizations. The documentation on how much parallelism isn't really well defined in docs, so this is what we figured out. And so in singleton mode, essentially the number of partitions times the number of messages in a batch is what you're going to get, whereas from a batch, the number of messages at a time are based on the number of partitions you've got. Now, let's try and figure out why I end up having duplicate messages being processed. Now, in this world, imagine you've got a situation where someone's not eating the cake fast enough, and you go, I want to get someone else to start eating that bit of cake. That's essentially what the event host does. It goes, actually, I want this other person to come and eat your bit of cake. Now, the way this works in the function world, it creates another function app. Now, it checkpoints a batch, and that batch is being processed by this unit. Now, when this starts, the checkpoint is at the point before this started, and so it starts processing the same batch. This does not know that this has started, and this doesn't know how far this one got through processing that batch. The fundamental point is that these messages will get processed twice. So you have to make sure that your code is idempotent so that it doesn't matter that it's going to get processed twice. And every time it will scale because essentially you're not processing your messages fast enough. So scaling isn't free. Each host takes ownership of our partition and end up reprocessing those messages. You really want the scaling, but you've got to accept the fact that you will get duplicate processing, and you have to process your messages in an idempotent way. So how do we know all this? Well, App Insights is the thing. I showed you all the diagnostic information that we had. It's very easy to enable. Just pull in the NuGet package, and you get all of it lit up for free. Put your instrumentation key in, and you get all the throughput, all the exceptions, and it becomes very easy to go and process it. So in summary, it's not magic. You can't just go and throw a whole load of workload. You've got to think how it's going to scale. You've got to think about that concurrency and how batch reading was going to help you. One of the things I haven't really talked about is asynchronous versus non-asynchronous code. The solution is you either have all asynchronous code or no asynchronous code. If you try and return a non-asynchronous method to the event host, and within it you call an asynchronous method and do a task.wait, you will starve your thread pool and your system will just grind to a halt, and you'll wonder why your messages aren't getting processed, and they're not getting processed because you've run out of threads because of the way that the thread pool locking starvation stuff works with asynchronous waits. So all asynchronous or non-asynchronous. Asynchronous is generally by far the better, much more scalable model. Understand things like connection pooling and make sure you log, because you can't run these things. They're not running on your VMs. Now, nicely, it will run on your own machine because there's the function runtime, but fundamentally, your desktop is probably not a single core machine. And therefore, you will get different behavior on your machine than you will on in real life. So you've got to be prepared to do that diagnostic using App Insights. Fundamentally, SQL was the easy part. That scaled amazingly well. I mean, we didn't even really get functions going bonkers, and we were still getting processing of half a millisecond for each query. So it just goes to show that 10 millisecond guarantee for Cosmos. SQL can do half a millisecond without breaking a sweat. If you've got any questions, ping me. I've got some business cards and some Packer cards if you want them. Come and ask me some questions, and I'll be putting this sample on GitHub over the next couple of weeks. So feel free. Thank you very much. Any questions? The retry pattern. So we created another queue and basically sent those messages off to another queue. So you have to implement the classic connection retry logic from a database perspective. It all depends on what failures you're occurring. We generally tried to classify them as failures that were data quality related, and therefore they were poison queue type failures, compared to transient connection failures, and then we would retry those. And if you can break your function down into a single processing unit, largely it means you can reprocess that function probably 4 or 5 times. And what we did was we just put the payload with a header that said what the retry amount was, so that we could then do a counter so we wouldn't end up retrying this message all to exhaustion. Go. How did you implement the idempotency? It all comes down to whatever system you're running. So in our case, we just had a model which, if we had processed the customer before, then we could figure out that we'd processed it to completion, and then we would just return the complete customer that we'd already processed. But it becomes more complicated if you're going to do like payments. Essentially, you've got to put some traceability tracking in to make sure that when you process that you either do it again or you don't do it again. I mean, fundamentally, those are your 2 choices, but it's down to whatever your scenario is. The easiest thing is just to do it again, but if there are side effects, then you don't want to do that. So. Cool. Thank you very much, guys.